Hello friends, today we are going to discuss about one of the important topic in genetics about sex determination. You know, sex determination. The concept of sex determination always intrigues researchers from the very beginning because it is the basis for our very existence. Concrete cytological evidences in insects proves or laid the foundation for the concept of chromosomal or genetic basis of sex determination. Before we go into the topic of sex determination, we have to learn about certain basics like what are sex chromosomes in a hierarchy. You know, sex chromosomes or otherwise called allosomes. You know, a pair of chromosomes which are essential in determining the sex of an individual are sex chromosomes or allosomes, and the chromosomes other than the allosomes are called autosomes. You know, Henkin in wasps, while he is investigating the spermatogenesis thing or research, he has identified a specific nuclear structure that has been seen in throughout the meiotic divisions, and wherein that specific nuclear structure has been transformed to the 50% of the sperms, whereas the rest of the 50% of the sperms didn't contain that specific nuclear structure, and he identified and named it as X body. You know, Henkin in wasps identify X body. Actually, he doesn't know exactly what is the role of X body. He just named it as X body. Okay. Later, or that means further investigations proved that that particular nuclear structure, what we call X body, is a chromosome called as X chromosome. You know, known as X chromosome. Later, Stevens and Wilson, while they did perform the research on mealworm, discovered Y chromosome, and they have identified that Y chromosome had a role in sex determination. Here, the sex of the offspring depends on the presence or absence of Y chromosomes. So these two are the stepping stone for the concept of chromosomal or the genetic basis of sex determination. So on the whole, the point is simple. Sex chromosomes or allosomes are the essential in distinguishing the sexes. That means male sex and the female sex are determined on the allosomes of sex chromosomes. And Henkin is the first one, and followed by Stevens, because he identified the X body as later onwards identified as X chromosome, and Stevens and Wilson and with respect to Y chromosome. Regarding other basics, there are two important keywords that are essential in understanding the concept, known as homogametic and heterogametic. Homogametic and heterogametic. You know, homogametic, the word it implied similar gametes with respect to what? If the individual produce similar gametes with respect to one particular kind of sex chromosomes, that means that particular individual have similar sex chromosome. There are no different or dissimilar sex chromosomes. Say all the gametes contain one particular sex chromosome. Say XXXY with respect to, I am saying, with respect to XXXY, in case of XX female, all the female, that means all the ova contains X gametes. Whereas heterogametic, the name it implied, different kinds of gametes. Differences is because of production of different gametes with respect to different sex chromosomes. That means two different sex chromosomes or dissimilarity of sex chromosomes is a basis for heterogametic. Say XXXY in case XY, some sperms, half of the sperms contain X and rest of the half contains Y chromosomes. And with respect to ZW, Z and W, that here the not the sperm but ova. Half of the ova contains Z and the rest of the ova contains, that means the rest of the 50% contains W. That means here the two kinds of gametes will be produced. So they are called as heterogametic. And on the whole, that means with respect to broad concept of sex chromosome, that means sex determination. There are three popular theories, sex determination concept. Entire sex determination concept depends on three popular concepts. Number one, chromosomal theory of sex determination or genetic basis of sex determination. Number two, genic balance theory. Genic balance theory. Number three, haplodiploidy. Haplodiploidy. These are the three popular concepts and most, like in research point of view, are empirically authentic concepts for sex determination. Okay, chromosomal or genetic basis of sex determination, we have discussed about the same. The genic balancing, we will discuss about it, and haplodiploidy. First, the chromosomal basis or genetic basis of sex determination. This is the most common concept because most of the animals belong to this category. Most of the animals belong to this category, chromosomal or genetic theory of sex determination. Much specifically, heterogametic basis of sex determination. We have discussed the two words, homogametic, which produce similar gametes. Heterogametic, two different gametes, one gamete with one sex chromosome, the rest of the 50% gamete with other kind of sex chromosome. Heterogametic, the word it implied here, the individual particular species produce two different kinds of gametes, and the sex of the offspring depends on which particular gamete fuses with the common gamete. That means, say here one particular individual belong to one particular sex produce all kind of similar gametes, homogametic, whereas the other individual produce two different gametes, what we call heterogametic. Here the sex of the offspring depends on these two gametes, that means produced by heterogametic individual. Which gamete fuses with the homogametic individual determines the sex. This is a broad concept of heterogametic sex determination. That means chromosomal basis or genetic basis of sex determination completely depends on the concept of heterogameity. Maybe male heterogameity or the female heterogameity. That means which gamete fuses with the homogamete. Which determines the sex of the offspring. Okay. According to the concept we have already discussed, male heterogameity and female heterogameity. First, male heterogameity. Again, I have two kinds, XX, XO type and XX, XY type. First, XX, XO type. This kind of sex determination is seen in some insects like bugs, grasshoppers, McClung identified this concept, in grasshopper. Identified this concept in grasshopper. XX, XO, we have to focus on the fundamental issue so that we can understand better. Okay, XX, here we have discussed that male heterogameity. That means male is a basis for sex determination. Heterogameity means male produce two different kinds of gametes. That means one particular gamete contains one kind of sex chromosome and the other particular gamete contains other kind of sex chromosome, what we call male heterogameity. So depending on the kind of sex chromosomes, and that means number and nature, there are two types, XX, XO type, XX, XY type. It is common in some insects like bugs, grasshopper, cockroaches as well. Okay, say McClung identified this concept in grasshopper. Okay, cockroaches as well. XX, XY means here the word it implied. XX means the female, so both gamete all the ova contains one particular X, whereas male contains two kinds of sperms, X and Y. So it's the simple. So the gametes is considered as parents and the gametes X, whereas sperm contains two different kinds. Here O means no, it doesn't contain any. That means half of the gametes contain X and the rest of the gametes doesn't contain any sex chromosome. That means unpaired sex chromosome. This is very important. Unpaired X chromosome is the basis for determining the sex. And which is unpaired? Male, what we call male heterogametic, which produce two kinds of gametes, one with X and one without X. So simply have unpaired X chromosome. That unpaired X chromosome is the basis for sex determination. Okay. Then this is X in case of X and the two kinds of sperms. When this finishes with X, this will form, just I didn't draw the autosomes. That giving the just for simplifying. One, that means one autosome from male and one from female. That's simple. Okay. For simplification, I am presenting like that: AXX and AAXO. If for better understanding. Okay. That means it is a female and this is a male. This, however, discussed male heterogamety. Unpaired X chromosome determines the sex of the offspring. That means the sperm is a deciding factor. Sperm is the deciding factor, not the egg. Then coming to the second category, that is called XY. XXXY type. XXXY. Okay. This is common in, we knew that human beings and insects like Drosophila. XXXY, okay? The same concept, male heterogamety. All the ova contains one X, that's it. Whereas sperm contains two different sperms, AX and AY. If this X fills with this, AA, XX, that is female. If it fills with this, AA, XY, that is male. Again, the sperm is the deciding factor. XXXY is the sex determination method in human beings and also in insects like Drosophila. In human beings, we knew that we have 23 pairs of chromosomes. That means 22 pairs are autosomes and one pair are allosomes. And when a particular somatic cell, doesn't matter whether male or female, contains all are similar, means autosomes, which are 22 pairs. And that one particular pair, what we call allosomes, distinguishes a male from the female. The female contains both XX chromosomes. Here, male contains one X and Y chromosome. That means again the sperm is a deciding factor. That means depending on the kind of sperm, whether the sperm contains X or the Y, determines the sex. If the X containing sperm fills with the egg, it leads to female offspring. If the Y containing sperm fills with the egg, it leads to male offspring. The point is similar. Here, the female is homogametic. All the X split contains X chromosome only. Okay. So the point is here between the difference between this and this. That means XXXO, XXXY is depend here. Not only just the male gametic, that means male heterogamety is a basis for sex determination. That means sperm, but number of chromosomes are also different. Number and nature. Number and nature means here male individual contains one sex chromosome less, and this also basis for sex determination. Here not just the the sperm, but kind of what I say, the kind of sex determination depending on the differences in the number of sex chromosomes also. The female contains 2 X chromosomes and male contains 1. That is why we have discussed unpaired X chromosome determine the sex. Unpaired X contains is male. This is very important. No, AXO. That means AAX and it doesn't contain another X chromosome or any other kind of chromosome. Okay. And in case of here, it is not just the number but the nature of the chromosome. That is why I told you now, Number is here, nature is here. Both male and female contain exactly the same number. Unlike here, which here the male contain one sex chromosome less. Here both male and female contain same number of sex chromosome, but the nature is different. Here the female contain XX and male contain XY. In place of second X, there is Y in case of male. That means nature of the sex, it is what we call sex determination based on the nature of the sex chromosomes as well, and it is XS, example human being and Drosophila. Okay, then it is about male heterogamity. Then the second category, female heterogamity. Female heterogamity. Female heterogamity. Again up to types, ZO, ZZ and ZW, ZZ. It is common in moths like Fumia and some butterflies. Fumia. And this is common in birds, reptiles and some fishes. The word it implied, female heterogamity, just like in male heterogamity the sperm is the deciding factor, in female heterogamity is a ova that is the deciding factor, because the different kind of gamete, the nature of the different kind of gametes restricted to ova, that means the female sex. Whether it can, either it may contain two different gametes, that means two different sex chromosomes, or just one sex chromosome, just like the male heterogamity, XXX1 only X in case of male, XXXY X and Y in case of male. Here are the same concept, ZO, ZZ. That means two different kinds of ova are present, one with Z chromosome and one without any chromosome. That means no sex chromosome. So unpaired Z chromosome is a crucial factor in determining the sex. That means AZO become female, AZZ. Here the sperm contain all this. That means similarity of sperms. All sperms contain Z chromosome. Unlike ZXY, what we have two kinds of sperms. One is X and one is Y. XY leads to male offspring, XX leads to female offspring. Here the thing is, all sperm contains Z chromosome. Here this kind of ZO, ZZ base of sex determination is common in moths like Fumia and some butterflies. See, ZO, ZZ. AA, ZO and male. AA, ZZ. The gametes. AZ, one egg and A and AZ sperm. When this egg fills with this, it forms AAZZ, and this forms AAZO. This become male, okay, and this become female. That means here the deciding factor is egg. Egg is the deciding factor. Got it? Same concept but reverse. Egg is the deciding factor because egg contain, half of the egg contain Z and the rest of content doesn't contain any sex chromosome. Okay, then ZW, the same concept, but here the thing is, I told you that just like XXY nature, ZW is different. AA, ZW, AA, ZZ. Number is same but nature is different. Male and female contain same number but the female contain two different sex chromosomes. Okay, half of the egg contains AZ, the rest contain AW. So if you have one particular sperm, okay, this leads to male, okay, AZZ, and this leads to female, AZW. Okay, again the egg is the deciding factor. Okay, that means ZW, ZZ. This is common in birds, reptiles and some fishes. ZW, that means half X with Z, rest of the half with W. And the sperm is all sperms contain Z chromosome. So egg is a deciding factor. Okay, this is about chromosomal theory of sex determination. Here the thing is, we based on this we can come to an inference that certain genes present in sex chromosomes are responsible for the determination of sex. Is that common or what we call, is it there is absoluteness? Not exactly. In science or nature, you cannot expect absoluteness. There is always a concept of relativity. Okay, same concept here also. Certain organisms, let me say like Drosophila melanogaster, it is not just that means the sex chromosome, but other issues are also determine the kind of sex, and this is called genic balance theory of sex determination. Genic balance theory of sex determination. Okay, second category. Just understand this word, genic balance. Gene balance. Gene balance is a basis for sex determination, worked out by Kelvin Bridges. Worked out by Kelvin Bridges in Drosophila melanogaster. Kelvin Bridges, one of the student of Thomas Hunt Morgan, and he has worked on this principle, this concept. What exactly it means to say is, in case of sex chromosomes, one kind of sex that depending on the kind of sex chromosome, we can decide whether it is male or female. But here, not the same concept. Here, the concept is different. That means that the genes responsible for femaleness present on X chromosomes, and the genes responsible for maleness present on autosomes are the basis for sex determination. To be clear, it's simply X chromosome is concept. That means here the ratio of sex chromosome and autosome. This is very important, what we call sex index. To determine the sex, here the ratio of the sex X chromosome, that means number of X chromosomes, and the number of haploid sets of autosomes, what we call X by year or sex index, is the basis for sex determination in Drosophila melanogaster, what we call Kelvin Bridges theory. Genic balance, gene balance between the X and the autosomes. That means number of X chromosomes, number of X chromosomes, and number of haploid sets of autosomes determines the sex of the offspring, that means Drosophila. See how this concept emerges. While he working on the Drosophila, he has identified a concept called non-disjunction. This is very important. Non-disjunction. Non-disjunction means it failure to separate. We knew that disjunction takes place. That means the chromosomes, they separate or segregate during the anaphase stage of meiosis. We knew that, okay. But during this anaphase stage in Drosophila, disjunction is not taking place. What we call non-disjunction, failure to break apart. And because of this non-disjunction, it leads to abnormal gametes. That leads to aneuploid zygotes. This non-disjunction leads to abnormal gametes. Abnormal gametes that leads to aneuploid zygotes. Aneuploidy means that chromosomal number which is not the multiple of the haploid chromosomal complement of the species. For example, a 23 pairs we have, so 23 is haploid, double means 46. It is normal complement of chromosomes. Say 47, it's not the normal. That means what we call aneuploidy. That means one chromosome extra or one chromosome less, 45. It's called aneuploidy. That means the number of chromosomal complement is not cannot match to that of the multiple of the haploid chromosomal complement of that particular species. This is called aneuploid, and aneuploid zygote leads to always abnormal individuals. And while he identified different things, the most important point is, say generally AAXO. Just look at on these two pictures, AAXY and AAXXY. AAXO becomes male. AAXY becomes female. This is something not surprising, because We have discussed XX, XY is the basis for in case of Drosophila also, but here there is no Y, but still the offspring become male. And here there is another, that means what we call aneuploid now. In addition to 2X chromosome, there is one more Y is there, but still it becomes female. That means though there is a lack of Y chromosome, the individual become maleness, but though there is a Y chromosome, the individual become female. This is what something interesting, and this has explained, that means the resultant because of non-disjunction, and this leads to concept of genic balance theory. These are resultant because of non-disjunction, which evolve the concept of genic balance. This is very important. That means that AXY is normal male. Okay. These are, if you understand this, we can understand. Okay. For better understanding, I will tell you. And he has crossed a triploid female. He has crossed a triploid female with a normal diploid male. Triploid female, I told you, na? Abnormal gametes because of non-disjunction. Triploid female with a normal diploid male. That leads to different gametes, like AX, AAX, AXX, like that. And we can, for better understanding, we have to draw a particular example. Okay, say chromosomal complement. Here AX means normal, one, this is again abnormal and again abnormal. Okay. Chromosomal complement. Then X by A ratio, what I have discussed. Okay, sexual phenotype. Here, say the first chromosomal complement AAXX. Here X by A ratio, 2 by 2, 1, become female. Then AAXY, that means again 1 by 2, 0.5, that means become male. That means 1 by 2, okay? Here Y doesn't have any role. Then AAXX and AAXXX. These two are very important, no? 2 by 3. That leads to 0.67. And this is 3 by 2. That leads to 1.5. This becomes super or meta female. And this become intersex. And one more thing, AAAX. That means 1 by 3 is to 0.33. Super male. Okay, I didn't give the enter the list, but the most important, each category, that means one particular being from each category. Okay, AAXX, we knew that obviously is to female. AAXY is to obviously male. But consider on these things. AAXX 2 by 3. Here we told the ratio of X chromosomes and autosomes. If the ratio is between, this is very important, between 0.5 to 1.0, then they become intersexes. And if the ratio is greater than 1.0, it becomes super or meta female. If the ratio is less than 0.5, then they become meta or super male. Here, apply this concept here also. AAXX to 2 by 3, 2X chromosomes and 3 autosomes, 0.6, and then it will become intersex. Intersex means abnormal, that means bisexual gonads but at rudimentary state, but abnormal morphology. Here, AAXXX, that means 3X chromosomes and 2 autosomes, that means 1 by 1.5, the individual becomes super or meta female. And AAX, that means just 1X chromosome and 3 autosomes become 0.33, super male. Here, super female or super male, both are infertile. This is very important. We have already discussed. Here, Y chromosome, no role of Y chromosome. This is very, very important. Here, the thing is, Y chromosome, actually Y chromosome contains an important male determining factor, what's called TDF, testis determining factor, synthesized by the gene called SRY gene, sex determining region on Y chromosome. Gene synthesizes TDF and this determines the maleness. But this Y chromosome doesn't have such a role. So Y chromosome is like blind. So it doesn't matter whether how many Y chromosomes are there. Just the X by A ratio determines the kind of sex. But the Y chromosome do contains information for fertility. For example, we have discussed AAXO. Though it is a male, but it is a sterile male. Because it doesn't contain Y. Because Y presence is important for fertility, but not for the sex determination. That is why, on paper, though we believe that AXY leads to this male, as usual, like XXXY method of sex determination, but the practical is different. It is not the XXXY, but the genic balance theory, but it happens to be male because of Y chromosome, because of fertility nature. But Y exactly doesn't have any role in sex determination, but the X by A ratio. That means 0.5 is for male. If a particular offspring should become male, it should have 0.5 sex index. If you want to become female, it should have 1.0. That means sex index of 1.0 become female and sex index of 0.5 become male. This is very important. And it's about genic balance theory of sex determination. The balance between, that means the balance between X chromosomes and that of the autosomes is the basis for sex determination. Okay. Then the last category, what we call haplodiploidy. Haplodiploidy is a very simple concept. Haplodiploidy.